Greetings, folks. Am I audible?
Yes.
Yeah. Greetings, everyone. A very warm welcome to the Kubernetes Chaos Engineering Meetup. This is Prithvi, Community Manager for LitmusChaos, and I welcome you all to this Kubernetes Chaos Engineering Meetup where we talk about everything chaos. So before moving ahead, I would like to start off with the agenda for the day. And as you can see my screen, the agenda for the day includes Keynote by Raghavendran Venkataramana, Senior Manager from Verizon India. Following up by that, we'll be introducing Cloud Native Chaos with LitmusChaos, which will be done by me, that's Prithviraj. Followed by that, we'll be talking about the continuous probes that we talked about in the previous meetups as well, that will be explained by Shubham, which will be followed by chaos scheduler enhancements, where we talk about scheduling chaos, which will be done by Sanjay, Nathani. Followed by that, we talk about the alpha version of the Litmus portal, which was just launched in the release on the 15th of September, which will be explained by GT Shomo. We also have a guest amongst us, Shaik Jaffer Ummer, who is an MTS4 Kubernetes consultant at Verizon, who will be talking about rejuvenation of Kubernetes nodes using chaos engineering. So I hope you all are excited for the meetup today. And before wasting any time, I invite on the floor Mr. Raghavendran Venkataraman, Senior Manager from Verizon.
Hey, thanks, Prithvi. Hope I'm audible to everyone.
Yes, Raghav.
Yeah, thanks. So good morning, everyone. Hope everyone is safe and doing good. As Prithvi introduced me, my name is Raghav Venkataramana. I'm a Senior Manager with Verizon India. I take care of the Kubernetes platform and also monitoring as a service products for Verizon. GTS is our organization within Verizon. So I have like close to 20 years of IT experience, my 20th year with IT in two companies. Right. So very nice to see a lot of engineers joining this meetup on a Saturday morning. We have been conducting meetups in Verizon for the past 2 years. We generally do it on a Friday evening because it's very difficult to pull the crowd, especially from Verizon on a Saturday on a weekend, right? So that's why we thought let's do it on a Friday evening, and we have been receiving a good feedback and good, turnout in terms of all the meetups. So we have been doing this both in Chennai and Hyderabad, alternating. We cover various topics. Just introduction to that. So we named it as VZ Tech and Me, right? So one good thing about Meetup is we also do a lot of other tech events in Verizon, but one good thing about Meetup that I have seen personally is because I take care of conducting this Meetup here in Verizon. So the turnout or the crowd is much more larger than the other tech events, right? Basically, it's because this is kind of an event where it is done for the engineers by another set of passionate engineers, right? And the topics and everything that we choose is basically what every other engineer would want to listen to or know about it, right? So it's basically like a community thing. And we see a lot of good crowd and good knowledge sharing happening and a lot of questions as well, right? So that's a very good thing. Unlike other events where we had to do a lot of marketing, ask people to join and things like that. So that's a very good thing I basically like about meetups. Right, so I was pulled into this particular meetup only yesterday evening, so I haven't prepared a lot for this keynote or something. But the moment I saw the chaos engineering meetup, right, I got to remember of one incident or one thing, or probably a short story that I wanted to tell you guys, which is like 15 years back when I joined Verizon as a senior analyst or so, right, in 2015-16 timeframe. So we had a small team, 15-20 members, and I can tell you that we were DevOps even before DevOps was a cool thing, right? So we were doing DevOps those days itself, not with the tools and other things, but with the team composition. I mean, right? We had like 8 to 10 developers. There were a few testers. We had a bunch of business analysts, and also a couple of system administrators who would double up as a DBA as well. So this was a composition of the team. Everything, development, ops, everything was done within the team itself. So our senior DBA comes, SA, is like a very cool guy. Okay, so we used to manage like 15, 20 small to medium sized applications, right? So there's not a whole lot of process, documentation, all those things, because every person had to manage multiple tools and applications from his side. So it's no time for to do all the documentation and things like that. So this guy, the cool DBA, the SA that I'm talking about, used to manage all the servers, databases, everything. Imagine if we have to manage for 20 different applications, so many databases, test, dev, production, everything he has to manage, including the servers. Very often he used to refresh the servers or consolidate the servers or move things over from one place to another. There are a lot of initiatives that would happen. They will do tech refresh where they move from physical to virtual. They will do data center consolidation where we'll have to move from one data center to other. So all these things used to happen on a frequent basis in Verizon. So what he would do is he would move all the stuff from one place to another, right? So database, application, all those things. And some of the small things that he would miss out, or I mean, he would not miss out. The people would miss out, the developers. One thing is like the Windows scheduler jobs that you would set up in the servers, right? So nobody would remember that. It is very difficult to name it properly to make sure that who owns it and things like that. So what this guy would do is he will send out an email saying that, hey, I'm moving the server. Please make sure that all your stuff is moved over from this server to another server, right? So some of us will do it and we'll reply back, confirm him. Some of us will do it, will not reply back to him. A few members will totally ignore it. We also had some team members in US. So these guys will not even remember or ignore it and then leave it as it is. So our cool DBA will wait for some time, a few days. If nobody replies or if he doesn't get 100% confirmation, one fine day when everything is silent, he will pull the plug off, right? So he will wait in the evening, late evening, and wait for a couple of hours and find out what's happening. Suddenly the users, when the US morning time comes up, suddenly the users, the end users, of course, they are internal users only. So not a big deal, right? But still, these people will start screaming, why my thing is not working, this thing and nothing. So then the developer would jump in and find out what has happened, right? So then you will realize that, okay, this is something happened to the server or this job is not working and whatnot. Then you will ask a DBA, the cool guy, and what happened? He will silently say that I only pulled the plug. I know you would come to me. I've been telling you to move this stuff over, but you have not done that. Please do it now. I'll start the server and start the service now. So that's what he would do. That was like a chaos monkey test or whatever you want to call it. That those days we were doing it. He was doing it very often, but it was not named like that on those days. Probably we were doing it without knowing what we were doing. So this is an incident that came to my mind. Why I'm saying this is making sure that we have proper documentation, making sure that we know what to do in terms of a worst case scenario is very, very important. And I believe that is what you guys always, I mean, most of the times discuss in this meetup. This week, we are going through a big event in Verizon. Hope you all know that Apple has launched some products. Unlike previous years, this time they have staggered the launches. They have just launched the Apple Watch and the iPad, one version of iPad yesterday. But usually they would launch all the products in one day, and it will be a huge event for Verizon in terms of number of people coming to the website and start ordering things and start ordering iPhones. iPhones is like crazy in US. You probably know that. So people used to order that in one day within just after the event opens or the launch is happening. So we do the prep work for like 4 or 5 months before this, making sure that everything is perfect. Even with all those things, there'll be some hiccups, some issues, right? So it is very important that we make sure that we prepare ourselves for the best. At the same time, we should also prepare ourselves for the worst, so that we can handle the situation in a better way, right? So with that, I will stop here. I'm not going to stand between you and all the list of speakers or the list of things that is going to come up. I saw the agenda, a lot of cool stuff that is coming up. I also have one of my team members, Jaffer, who's a Kubernetes engineer, who's going to do some, talk about it at the end of the session. So I wish you all the speakers the very best for this event. And thank you so much, Prithvi and others organizers for giving me the opportunity. Everyone have a good session and a great day. Thank you so much.
Thank you, Raghavendra. That was indeed insightful words from you, and we're looking forward to hear more from you in the upcoming meetups. Moving on to our agenda, we have on hand talking about cloud native chaos with Litmus. So, as you all know, chaos engineering is the fundamental to increase the resilience of today's systems or applications. Now we all know, I would like to give a couple of examples here. Let's say we are having a sale on Amazon, or we are having a lot of a boost in users on Netflix. So how does the system handle that? How does the system react to it? Although resilience is present in systems, but then again, it's not very necessary for the system to react in such a way that it can hold on to the number of users that are joining in. So obviously, what does that lead to? That leads to downtime, that leads to outages. And what does that, like what are the repercussions? Loss of money, loss of time, and also any mishaps in the system, which can obviously lead to so many various conditions where you cannot go back to what was present there. So what do we emphasize upon here? That's resilience. So what is resilience according to you? Resilience is the ability of any system to resist faults or outages that are happening. And why do we emphasize on chaos here? Because chaos engineering helps you test the system before even any outage occurs. What we believe in is the chaos first principle. So what is the chaos first principle? Why not test the system before any mishap or outage happens? Why test the system after that? So chaos engineering, as you all know, is the act of inducing or putting out a fault deliberately into the system to check any extreme conditions or chaotic conditions that might bring the system down. And when we talk about Litmus, which is a tool set to carry out cloud native chaos, LitmusChaos is a tool set which is part of the CNCF sandbox, just landed into one in June 2020, and helps you carry out chaos in a cloud native way. So what is the cloud native way of carrying out chaos? The cloud native way of carrying out chaos involves four main principles. The first principle is that chaos should be declarative. That is, Litmus provides chaos CRDs to manage chaos using chaos APIs, orchestration, scheduling, and complex workflow management, which can be done in a declarative way. The second thing is obviously open source. As you all know, we emphasize upon the world of open source technology, and Litmus is an open source toolset where anyone can contribute any experiment. Now we all know that the pool of experiments that are there are present in the Chaos Hub. I would just like to share my screen to present the Chaos Hub to you. So as you can see, this is the Chaos Hub that we have, and this is for the users who are joining in new to pull out any experiment. And there are a pool of experiments. Let's say what happens in a Kubernetes architecture. So you can see, as it's on my screen, a generic chaos experiment. A generic chaos experiment is basically involving chaos experiments that happens in a very generic outage. What is a generic outage? You can obviously delete a pod, or you can have a k-test pod delete, you can have a container kill, you can have a node cpu hog. There are various outages that can occur, and using the chaos hub, which is having more than 33 experiments, you can pull out any experiment, and you can also induce chaos using that. So moving on to the next factor, which is chaos ready experiments. So most of the generic chaos experiments are readily available for you to get started with your initial chaos engineering needs, to get started with the initial outages that you want to work with in your applications. So what makes Litmus the go-to tool set? The fact that you can create your own experiments. For Litmus, you have got the SDK available in Go, Python, as well as Ansible. And a basic structure is quickly created using the SDK for developers and SREs. SREs, as you know, are coming up, and a concept which was put forward by Google. And SREs are the one who just help you add that chaos logic into the new experiment. They help device system reliability. So the last point that I would like to make here are the chaos workflows. You have got simple chaos workflows that that can be easily constructed. You just have to use GitOps and the chaos workflows to scale your chaos engineering experiments. Any experiment can be scaled, and which will lead to increasing resiliency for your Kubernetes applications. So what is next in the roadmap? Obviously, we have got a pool of contributors, and I invite all the participants who are present here who are Kubernetes users, enthusiasts, and developers wanting to use chaos. We have just got a Litmus portal which will be explained by Shomo, and which will help you manage and orchestrate chaos in a very better way. So without wasting any further time, I would like to open the floor for questions. And if we don't have questions, we'll move on with the agenda. So do we have any questions? Okay, so as I can't see any questions, probably you can ask the questions on chat, and anyone from the team or from the Litmus Chaos contributors team will be free to answer the questions. So the next agenda that we have in hand is demonstrating Litmus continuous probes, extending the Litmus probes that was explained earlier, and which will be explained by Shubham.
Thanks, Prithvi. Hello. Hi, everyone. I'm Shubham Chaudhary, one of the contributors of LitmusChaos. Prithvi, can you allow me to share my screen?
Yeah, I've allowed Shubham.
Okay, thanks. Okay. In the last meetup as well, I explained the probe and pre and post chaos probes. So now we extended it to continuous probe as well. So if you missed that missed that video, you can find in our YouTube channel LitmusChaos with LitmusChaos handle. And I will give a brief introduction of probe as well for the new so that you can get the context. In our chaos experiments, we have some hypothesis. We have some pre and post chaos check on the basis of which we decide our application is in our application resilient or not. I mean, it is a normal state or not. For example, our generic experiments have, for example, pod level chaos have application status check. We are checking the application status check in the pre and post chaos, and some of the our node infra or pod level node level chaos have auxiliary application check, means the dependent applications. We are checking the status of the dependent application in pre and post chaos check. We have some application specific experiment, for example, Cassandra. In Cassandra, we are checking for the node tool along with the application status check. And in the Kafka, we are checking for the message stream along with the application status check. So depend on your applications, we can have custom checks. So suppose if user wants some his custom check, so he want to introduce some custom check in pre and post chaos section or anywhere. So how he can do? So he can use two methods. First method is he can rewrite the experiment, create his own image, and then he can run the experiment. And the another method is we can provide him a declarative way so that he can use custom check as a pluggable. So he can provide a custom check at any place, and our experiment is capable of using those custom check, and we can get the result on the basis of it. So probe follow the second approach because it is difficult to write experiment every time, or it is not. Yeah, that's why we are using probe. So probe allow us the capabilities to define the custom check as a pluggable. We can define in our chaos engine, then our experiment can use. So I will go through the probe, chaos engine specs. So all these things, engine, state annotation, job cleanup policy, app details, chaos service kind of monitoring are, you already know. This STD, we can define this probe inside experiments.specs.htdb probe. So we have three type of probe. One is STD probe, one is KDS probe, one is CMD probe. So I will go through it one by one. So first is HTTP probe. In HTTP probe, this probe is used when we want to check for some HTTP URL. So what is it will do is we will provide URL expected response code as an input, and it will send a HTTP request, and it will verify the response code. And the mode of this probe can be or it supported 4 modes. For one is SOT is start of test. We are using it in a pre-chaos section. One is EOT, end of test. We are using in a post-chaos sections. Third one is age. It have both SOT and EOT. Fourth is continuous probe. This is, in our new release 1.8.0 release. So continuous is verified for the all, for the entire duration of chaos. We have, so now we have run properties. So run property is common for all the probes. It contains timeout interval, retry, and polling interval. So I provide some dummy, not dummy, I provide some my sample data for my chaos. So you can provide your data accordingly. Now we come to the CMD probe. CMD probe support 2 modes. One is a inline mode, one is continuous mode. So in inline mode, what we are doing is, in the CMD probe, we are running commands. On the basis of command, we are checking for the expected result. So if we, so here, to run a command, we need some binary, some dependency. So if those dependency already can be fulfilled by our Go runner image, then we are using inline image. We are not using any external image to run those command and check the expected output. But if we want some dependency, for example, in my case, I am using Cassandra, CQLSH command. So here we need some Cassandra binary. So that's why I'm using source image as Cassandra. So accordingly, we can use our image. So it support command input, expected result, and source. And it also supports all the 4 modes, SOT, EOT, ACE, and continuous, and same run properties as well. As an example, what I'm doing is here I am using CQLSH command and using grep and AWK to get my result. In the inline probe, I am using JSON path to extract some data, and then grep to get what we want, and then I'm using expected result to verify it. Then next is KDS probe. KDS probe is used when we want to check for some Kubernetes native resource. We want to verify is Kubernetes resource present or not, or something like that. So we can provide is GVR values, group version resources, and namespace, field selector, and label selector also we can provide here also. On the basis of label selector also we can find. And here it is also supporting all the 4 mode, SOT, EOT, ACE, and continuous, and run property also the same thing. So as an example, I have provide all the mode, SOT for this, and age for this, and for the initial 2 I provide continuous mode, so that we can get an idea of all. So in this example, I am using pod network loss as the chaos experiment. I have Nginx. I am using Nginx as a application, target application, and we can see chaos operator is already there. We can ping google.com here so that we can verify network is lost. Yeah, so we can create our chaos engine. Chaos engine has been created, so we can check here. The chaos pod will be there, so we can wait for chaos pod. We can see logs of this pod as well. We are printing some logs. Here we can see, after this every probe, here we are printing, depending on the probe is passed or failed, we are printing the probe, pass fail status, its data, what is it is pre or post phase, its pass or fail status, its name and type, all the probe detail. So helper pod is, I mean, it is running. So we can check that, we can verify that the network is lost. We are not able to ping google.com now. I mean, it will take some, because we have set the calculation system, it will take some time. So we are also creating events in chaos engine for the probe. So we can, meanwhile, we can check the chaos engine. Here we have we are creating a pre-chaos check event. Here we are using AOT as running, and probe is successful. So SOT probe is already done. So it is marked as successful. We can see, I mean, destination hosts unreachable means we are not able to ping google.com now. We can wait for chaos duration till, yeah. So chaos duration, I mean, it is 60 seconds is over. We can now see it is now again able to ping google.com. I mean, it come to the normal state. Now it is running age and I mean, continuous probe is already done. It will print the detail of continuous probe in the end of this experiment as well. So we can check that all the probes has been passed. We can see all events here as well. Post chaos check is also successful, and summary events is passed. We can also check chaos result. Chaos result contain all the details of probe. In the probe status section, we are putting probe name, its type and status. I mean, depend on a pre chaos, post chaos, or I mean both. This is the age case, so we can check it is pass versus fail here. We are also have this probe status percentage. Depending upon how many probes we have passed, we are generating this percentage score. And we can also check the verdict is also passed. So it is completed. Yeah, our experiment is, I mean, demo is done. Is any question? Okay. Okay, if anybody have any question, you can ask in chat. I also wrote a blog for this. I mean, I will provide the blog link in the chat. You can also go through it.
Thanks, Shubham. Thanks for that insightful demo of the continuous probe. Before we move ahead, I would just like to give an introduction to what Shubham explained or what exactly probes are. So probes are basically based on the declarative approach to chaos hypothesis, because like what is important here is one of the principles of chaos is the need to build a hypothesis around the steady state or desired system behavior, which gives rise to the litmus probes. And litmus probes are nothing but pluggable checks that you can define within the chaos engine of any experiment. So as you saw, this was one of the examples of the continuous probe, and for your information, Litmus just supports 3 probes, that is the HTTP, CMD, and K8S probe. So do check out the Litmus probes, which came out with the 1.7 version. Shubham has shared in a blog, which will help you get more insights on the Litmus probe. So moving ahead to the agenda that we have in hand, we invite Sanjay to explain more enhancements in the chaos scheduler.
Thanks, Prithvi. I'm Sanjay Nathani, one of the contributors in LitmusChaos community. Very good morning to all of you. Let me share my screen. So chaos scheduler is a controller developed on top of the chaos operator. I'll assume that all of you are now familiar to the chaos operator thing. Like chaos operator basically injects chaos in your cluster. Okay, so chaos scheduler, what chaos scheduler does is like it schedules your engines. Like what a cron job does to your jobs is a chaos scheduler to a chaos engine, like a chaos operator. So basically, I'll schedule one demo. So I've deployed a Nginx image here, like this one. It's a deployment of Nginx. Basically, we will try to delete its pod, this one, via chaos scheduler. So we are having all the chaos scheduler images here. Chaos scheduler GitHub. You can get the chaos scheduler in our GitHub and chaos operator. Okay, and v1.8, we are running the latest chaos operator image. So you can get the RBACs of chaos operator here. We'll apply RBACs now. Basically, chaos operator is a necessary element for chaos scheduler because it just schedules engine. Just verifying our chaos operator is up and running, and now the turn is for chaos scheduler. We'll apply its RBAC. Yeah, so our chaos scheduler is up and running. Now we'll get a watch on all our chaos schedules created. Yeah. And watch on all our chaos engines created. Yeah. So now, as you can see, I've taken this chaos scheduler GitHub repo, and we are having a sample chaos schedule CR in it. You can get it from deploy CRDs and chaos schedule CR.yaml. So in a chaos schedule, we are having two fields in its spec. One is the schedule one, and the other is the engine template spec. In engine template spec, you have to do nothing but um, paste a chaos engine spec. Chaos engine spec, you can get, you can generate a custom one based on your needs and your wants and how what chaos you want to inject. You can specify experiments and all in the engine template spec itself. Now the turn is for schedule. We have three scheduling strategies. One is the repeat, the other one's called now, and the yet another one is called once. So I basically start with the repeat one. Repeat is like basically a cron job to a chaos engine. Okay, so it specifies time ranges, it specifies the min chaos interval, what should be the interval between the two chaos injected in your cluster. It basically has work hours and work days. Work days include what days of the week you should have chaos injected in your cluster. Like you have a chaos schedule injected in your cluster, and so what you would like with the chaos scheduler to do with your cluster. And work hours basically injects the chaos in your cluster in specific hours of the day. Now we'll basically start with the properties only. All the other fields I've commented. Now let me apply it. So here we have given the min chaos interval as 2m, that is like 2 minutes. So every 2 minutes a chaos scheduler will create a chaos engine for you of this chaos engine spec in your cluster. So it basically will create inject chaos in your cluster in the interval of 2 minutes. So we have a schedule here, and you can see it will create an engine here, since it creates engines in the 2 minutes interval based on the sorry IST time. Like it will inject at 11, then 11:12. Currently it's 11:11, so we have to wait for the time to 11:12, and after 11:12 it will create the engine at 11:14. So basically 2 minutes intervals. And, yeah, and till that time we have the start time here. Start time, what basically it does is like it gives a time foundations to your um, chaos. And what end time does is like it ends your chaos at this time. After this time it there will be no chaos in your, like it is basically for production clusters. Yeah, so we can see chaos engine has been injected here, and it will form its chaos and do the needful. So let me get you familiar with the time ranges. It's 19th September, and the time accepted is the is not the IST one, but the GMT one. So we'll have to specify it according to that. It's currently 12, so approximately. So what this does is like it will create a schedule which will be created at 5:45. So in IST time it will be like 11:15 something, and after that it will stop the schedule at something at 5 on the 20th of September. So it will create a schedule for approximately 1 day, and we can inject the working hours here. So 0, I think 9 to 5, or we are having 5 currently. So 0 to 9 appropriate. If you want, you can also inject the work days also. As you can see, our chaos schedule has been deleted from here. we have the schedule created, and it basically says the exact 2 minutes interval, but it will just create a time foundation to our chaos of 20th September at 5 o'clock. Like it will be at something 10:30 or 11. So yeah, and introduce it. Yeah, so working hours are for a specific time of the day, like 0 to 9 we have specified. So it will create from 12 to 9. Starting of the day is 12, 00 hours, or we can term it as 12 hours, up to 9 hours. So it will basically create your chaos in that time only. It has a basic use of in the production clusters where where we want the developers to be present when the chaos is injected, so that they can confirm there is no uh, any chaotic confirmations in the cluster. So a engine has been created, and yeah, because it was a Saturday and we have included work days as Saturday, we can try removing the Saturday or change the working hours to 0 to 4, since it's currently 5 in the GMT, and we'll see that no chaos has been injected from there. Yeah, so schedule has been created, but now at 11:18 it will not create any engine, since it is not including the Saturday as the work days. So basically we'll have to wait to the 11:18 a.m. So you can use chaos schedule as a cron job to your chaos, and it's built on top of the chaos operator. Like it's using you can use you can utilize everything a chaos operator currently has, like KTS probes or the CMD probes, just Shubham explained. All the things we can specify there and just automate our chaos engine basically. So yes, it's 11:18 a.m. and yet no chaos engines have been scheduled. So uh, we can have two more strategies for scheduling the chaos. We just tried the repeat one. We have the ones that that specifies the time exactly when you want to inject the chaos at the exact time. So once will have an execution time field like these fields. You just have to fill that one and it will run smoothly. And yet another one is called now. Now will be the immediate creation of the chaos and no other fields will be specified. You just can specify now as a true there to inject chaos in that way. So, yep, that was it for the demo. Can we have some questions? You can ask any questions in the chat. Our team will be very happy to answer.
Thanks, Sanjay. Thanks for the insightful demo on the enhancements and everything about Chaos Scheduler. I mean, it's really exciting how you can schedule chaos. And I've sent in a blog so that everyone who's getting started with chaos can check out what a chaos scheduler is. Before moving ahead, for all the new folks who have joined us, I would just like to share a couple of things with you. One is the Litmus tutorials. For anyone who's not acquainted to what chaos engineering is or what Litmus is, the Litmus tutorials help you get to know everything about chaos with Litmus, from the architecture to the components to how to get started. So I'm posting the link for the playlist here. So whenever you get time, feel free to check out. And the second thing is inviting you all to our Slack channel. That's the hashtag Litmus channel in the Kubernetes workspace, where you can check out whatever is happening in the community, discuss anything you want to contribute. As you know, it's an open source project. And lastly, you can query or get a lot of learnings from the Slack. So I would love to invite you to the Slack, which I will be posting on chat as well. And moving ahead, we have the Chaos portal workflow, which will be explained by Shubham.
Hi everyone, I'm Shomo. Hopefully I'm audible. So,
Shomo, your voice is pretty low. Can you?
is it better now?
A little better, probably.
I think this should be good. Okay, so I'll continue. Yeah. Okay. So basically, I'll be giving a demo for the Litmus portal. So, but starting before that, I'll share my screen. So hopefully, I think it is visible now. So my screen should be visible now. Is the screen visible?
Yes, Shubham. It's visible.
Okay, so Litmus portal. So what is Litmus portal, right? So we already have discussed about Litmus and how Litmus is injecting chaos through different experiments, and how it provides a set of tools and SDKs to create your own experiments and schedule your experiments also, right? So where does Litmus portal fit in, right? So Litmus portal, the idea behind Litmus portal was to enable the users and SREs to create, schedule, monitor, and analyze the chaos experiments from one single place. And not just do that, but also enable them to collaborate with other SREs, other team members directly through this portal itself. Right. So the current scenario is that, like there was a question here, whether we can inject chaos in external clusters or not. So the current scenario is that if you want to run a chaos experiment on our cluster or a namespace, we have to log into the cluster and install pull all the SDKs ourselves and run the experiments manually, right? So that was the current scenario, right? But with Litmus portal, what we can do is like we can just install Litmus portal and log into the portal and schedule workflows, so chaos workflows basically, and run chaos across multiple clusters and multiple namespaces also. So from a single place. So you don't have to go and install Litmus specifically on all the clusters or namespaces that you want to run your experiments on and analyze the behavior. But all you can do is like you can just log into this portal and do all that from this single place. So that is the idea behind Litmus portal. I'll start off with a demo and show you how easy it is to get started. So I have a manifest with me right now. So that manifest is for the Litmus portal manifest only. It contains just the components that will show up, or it'll show after I apply this. So I'll just create the manifest, like create the resources, and I'll start the watch. So these are the main components that are being installed right now for the Litmus portal itself. So there's a Litmus portal frontend, there's a server, and a MongoDB server, a MongoDB database basically. So if I go ahead and open up the front end, it's starting up. So I'll open up the front. I will get my internal IP. So this is the front end port. So I'm gonna open this up. And as soon as these two components are up, we should be able to go with the demo. So right now the Litmus portal is being installed, but the front end is up, as you can see. So what I can do is once this server is up, I can log into the portal, and I'll be logging in as the admin account right now. So the Litmus portal right now comes in with a default admin account. So the admin username and passwords are also available in the manifest itself. So you can change that, and depending on your preference, you can put the admin username and password as you want. So all the components are starting up. So once I log into the admin account, it's right now set to admin and password is Litmus. So once I log in, I'll get a pop-up to create a project for myself. So this project is, as you can see, I'm the administrator here. So I can create a project for myself. I'll just quickly go through this. So the portal is now creating a project for me. So what is a project, right? So a project here is like a collection of users, clusters, and experiments. So a project contains like it's a abstraction kind of layer where you and your teammates whom you'll be inviting can add in their clusters and perform experiments specific to those clusters itself, right? So this is a home page, as you can see, and this is a admin account basically. So there on the left side we can see that there are a few tabs. First of all, I'll go to the home is this one itself. So I'll go to the workflows. So the workflow tab is basically the tab where you can schedule and monitor your experiments or chaos workflows basically. So if I click on this schedule chaos workflow, okay, so before that, I should show you this also. So once you log in, right? So at the beginning, when I first installed Litmus portal, there were only 3 components, right? So these were the 3 components. But after you log in, 2 other components are installed on the cluster itself. So there's an option in the manifest that allows you to toggle this feature. So what these components does is basically it installs the Litmus SDKs and also another component that lets you run the experiments and chaos workflows on this cluster itself, like on the cluster that where you're installing Litmus portal. So that is what these components are doing. So these components have been installed. So if I go ahead and click on this one and select continue, and then I can run any of these predefined workflows that are there right now. So we currently have 6 workflows. I'll be running the pod delete one because it'll finish quickly. So I'll run this one. So you have this page where you can edit the workflow according to your needs. Currently, we are providing this predefined workflow as a set of go-to experiments or workflows that you can run directly or immediately as you start off. But it also forms a basis for kind of best practices of creating your own workflows later on. So that is what these workflows are for. So now if I go ahead and create this workflow, and I can set a point performance weightage, and then I can schedule. So currently we are providing only the schedule now feature, but later on we'll be providing schedule later. That is like you can schedule your workflows later on also, and on specific times or intervals like that. So that feature will be coming in the next releases. So I'll finish off, and this should show workflow has been created, and I'll get an entry in the workflow table. And also if I go back into the pods, so you can see that there's a Argo workflow chaos pod delete that has came up. Now the experiment is running. So if I go ahead and show workflows, I should see a graphical representation for the workflow itself. So the workflow is running right now. So currently, as of now, we are just showing the details of how long the workflow is taking and all that details. We are not giving the logs of each of these stages basically. So a workflow, okay, so I did not explain what a workflow is, sorry about that. So a workflow is a little different from normal experiment, right? So in a workflow, we are using, right now for workflows, we are using Argo workflow. So that lets you not only schedule experiments, but also if you want, you can add in your own custom stages and steps so that like if you want to do something before running the actual experiment, if you want to set up your environment or something, you can do that. And also after the experiment, you can run other stages and or you can run it parallelly, and all those kind of things are possible with this workflow. So this is a current simple workflow. So it's a straight line, but we can have multiple parallel branching out experiments that go run parallelly and things. So we have a workflow for that. It takes some time, so I'll run it after this finishes. So this is the workflow that is running right now. So the first stage in the workflow was to install the experiment because currently my cluster was empty, as you can imagine, right? So I'm installing the experiment first before I'm running the experiment. Now at this stage, I'm actually running the chaos. So I should be able to see kube proxy runner. Yeah, so kube proxy pod delete runner. So this is basically running the experiment right now, and we should see this completing and turning into green, and there will be another stage called revert chaos. So that will be deleting the chaos components. So currently we don't provide the logs for each stage, but in the next release we are going to provide that feature also. So you can click on this, click on this thing, click on this stage, and you'll get a pop-up that will give you the logs of this particular stage, like how it went. If there's an error and it's logged in, it will show up in that log itself. So you can debug your workflows from there. So once it finishes, I can move on. So in this, so this is completely real time. So you'll see that this will change from running to succeeded or failed, depending on the status of the workflow. So once that happens, we can move on to the analytics part. So after workflow has been created and ran, so you'll see that we can provide from this portal itself, we can provide you analytics of how the workflow performed. So a workflow can have multiple experiments, right? So we can see, as of now, we can see which experiments failed, and we can give you a visual representation of it. So that will come up after this finish. In the future releases, we are planning to work more on the analytics part, so that we can provide more insight to the experiment and behavior of your system, overall system during the experiment also. So as you can see, the workflow has succeeded. If I go back to the show workflow, you should see that all 4 steps have completed. The revert chaos was also there. So that was the whole workflow. And now if I go ahead and show analytics, so it's waiting for the test to be completed. So while we do that, so in this page, basically what happens is that right now it's waiting for the experiment to be completed, I guess. So there's maybe some bug right now. So what happens actually is that we should be able to see the visual representation of how the current workflow has performed, right? So we'll get the pass and number of past experiments and failed experiments, and get a better idea of what has happened with the workflow itself. So that was the main feature of this Litmus portal, that was creating and scheduling and monitoring the workflows directly from this Litmus portal. Right now we are doing it just for the current cluster, but later on we'll have a feature in this next release, upcoming release, that is in October 15th. We'll have the feature of connecting external clusters. So you can basically choose which external cluster you want to run your workflow on, and you can run the workflows remotely from this portal itself. So besides workflows, we have the community section where we are giving insight about the Litmus matrices, like how many experiments that has happened yet, and what are the growth and all those kind of things. In the settings page, we have the default profile settings and also admin settings, because this is an admin account, as you can see. So I can change my name, email address, and password, all those things. And I can invite members to my team. If I go ahead and invite a member, right now there are no more users in this Litmus portal, so I cannot invite one. But I can create one user from the user management tab. So there's only one account right now, the admin account. If I go ahead and create another user, I can go ahead and create one. So the admin is so this admin account is going to create a user with a default name and password, and once the user logs in, he can change those details. So now the user has been created, so I should be able to see one more user here, and if I want, I can go to the team page and I can invite a new member. Okay, so the thing was not updated, I guess.
No, you have to log in using that user first.
Okay, so I'll log in first. So I'll log out and log in. Yeah, so I get this pop-up where I can basically set my details. So as you can see, the details are already pre-filled by the admin, so I can change it if I want. So if I want, I can change it to my name and go ahead. And I'll keep that as it is. So now it's updating my profile, and I should be able to see. So in the settings page, so this is not an admin account. So this is not a Litmus admin account. So we don't get that user management tab anymore. So the admin can only create the accounts, as you can see. So we do have the team page for this user's project. That is this one. Now, if I log out, I should be able to add this user as a member to the admin team. So if I go to team and invite a new member, so yeah, so right now we can see the user has been created and has logged in. So I can go ahead and invite the user. So I'll give the user so there are two roles right now. So there's an editor and a viewer. A viewer won't be able to create or create workflows. Basically, he can just view the workflows that have ran. So that's the only feature that the viewer will have. But editor can go ahead and create workflows in the project and run the experiments also. So I'm going to give this user the editor permission. So I'm done right now. So if I log out, I should be able to accept the invite invitation from this other account. So I go to the settings page and team, and from this option I can see the number of invitations that I have. So I think I need to refresh the page. Yeah, so I already have this invitation from the admin account. So if I can either ignore or accept, I'll go ahead and accept the invitation. So if I go back to the home page, and in the drop down I have a new project that is admin project. So I can switch to that project, and now I should be able to see the workflows that have ran in the admin project. But in this my project, there are no workflows, as you can see. So because I am the editor, I can go and create a workflow if I want, and the same flow will continue. So that was overall demo of the whole Litmus portal. In the next release, we are targeting to get the external cluster connect feature, and also a better workflow representation and logging for the different stages. We are also targeting better analytics and adding more predefined templates so that more experiments can be run and users can get an idea of how to create their own workflows, and also some minor performance improvements that are also in planning for the next releases. So that was all. If there are any questions, we can take it up. I guess there is no question. So I'll stop sharing my screen. If anyone has any question, they can post it in the chat and we'll answer.
Thanks, Shomo. Thanks a lot for that insightful demo of the Litmus portal. I mean, it's one of the most wonderful things that you can visualize chaos workflows and monitor them, and which enhances your chaos engineering experiments. So Litmus portal, as you know, the Alpha 0 version is already out, and we are looking for more enhancements, which will be released in the next release on October 15th. So I hope the community looks forward to that. Wasting no more time, we move on to the last agenda that we have, and we have a guest with us, Shaik Jaffer Ummer from Verizon, and he'll be talking about rejuvenation of Kubernetes nodes using chaos engineering. So welcome, Jaffer. The floor is all yours.
Hey, thank you, Prithvi. I hope I'm audible. Hello, everyone. My name is Sheikh Jaffer, working as Kubernetes consultant at Verizon. Thank you for having me. It's really glad to present my work in the Litmus Chaos Engineering meeting. With that, I will share my screen. Okay. So today we are going to talking about the rejuvenation of Kubernetes node roles. That is nothing but restoring or bringing back the node roles in the Kubernetes cluster. As you all know, CNCF releases their stable version of Kubernetes at least twice a year, and it adds new functionalities and feature for the orchestration and also for auto scaling or any new Kubernetes APIs, so introduction or from beta to stable version, anything in the new version. And also it deprecates some of the used functionalities that we have used in the previous version. So the most widely used feature was in our Verizon environment, also in most of the Kubernetes community users, the node rule. So the node rule is nothing but mentioning the Kubernetes cluster nodes as worker, as master, or segregating the infra parts as infra node, or anything like that, right? So the node role functionality was deprecated from 1.13 version, and it completely removed in 1.16 version. So we have a setup that is the AWS Kube model. We are running our Kubernetes cluster in EC2 instances. And when we try to upgrade our cluster from 1.15 to 1.16, we had a situation that this node role was deprecated and we are unable to move on. So I will explain you the chaos situation, what we undergone, and the solution that we have found out. So this node labels, right? So this looks like a small feature, but it enables users to segregate the nodes as master or worker, and also which allows the user to isolate the workloads. And we can specify the node affinity or node selector effectively. And it also helps to set up the auto scaling in the Kube AWS architecture model. Let me go to the next slide. So for instance, there is no, for instance, if we keep the node role as worker, so now if you log into any Kubernetes cluster, you can see the worker role or the infra role as none. So what happens if we keep the node role as worker? So if you keep the node role as worker, the kubelet service will fail to start, and it will throw us an following errors. You can see from the screen. You should specify the allowed prefix labels. That is kubelet.kubernetes.io or node.kubernetes.io. So it doesn't allow me to specify the node role before I connect the worker node to the AWS cluster. So this happens when the AWS scales out a new worker node, and it tries to join to the cluster to accommodate any pending pods that is running in the cluster. So as you can see, this is the screenshot from 1.18 Kubernetes version. You can see the worker node role as none. And what in our environment, we need those roles back for our auto scaling, for our pod scheduling, for our all the work that we do. For any application user wants to deploy their application to our Kubernetes cluster. So we are managing more than 1,000 plus worker nodes in our Kubernetes cluster. It's very hard to label the nodes manually. Like, the commands, right? So kubectl label node, and we can label the node, but that's not a solution, because every day tens and twenties of nodes spins out, and it scale in, scale out happens. So we need the solution to be automate. So we found a solution that is called a node watcher. So the node watcher is nothing but a Docker container, so which runs behind the Python script. So the Python script, what it does, the pod, so we are creating the node watcher as a deployment into the clusters. The pod keeps watch for the node events. So whenever any new node tries to join our cluster, so it looks for the node label. So sorry, it looks for what type of nodes it tries to add. Either it is the master or the worker nodes. So if it's a master or it's a worker, the node watcher nodes adds a node roles to the new node as master or worker appropriately. So this is a solution we have found out, and what we have done is we packed this as a container and we pushed it to the Docker Hub for any Kubernetes community users wants to make use of this feature in their Kubernetes cluster environment. They can make use of it. So with that, I will show you the demo. Okay. Just a minute. So I can show you the screenshots of what the demo represents. In the meanwhile, the server spins up. So it's just hanging right at the moment. Okay. So at the first command, I executed get nodes. So what happens? So when we execute the get nodes, the worker node role is none. So in the 1.118, so it starts from 1.116 versions and it continues in the future versions. So what we are doing is in the Python scripts, which looks for the condition checker. This is nothing but the nature of the node, either whether it is master or worker. So we are adding some particular label to the nodes. This is for the test purpose. I added manually. In our environment, we have added this label to the kubelet configuration. So then when the node comes up, the node comes with this label. So we are adding the node label as node.kubernetes.io, which is allowed label as worker. And even after you add it, you can see the node role as none. So what I'm doing is I'm creating a deployment from our Docker container solution that is nothing but node watcher, kubectl create deployment node watcher, and the image is the one which we have created, and the deployment will get created. So once the deployment is got created, you can see from the logs. So you can see the logs when you look at the logs, the pod itself adding the node as worker for the node 01. And you can see from the outputs, when you put get nodes, the node 01 has the role called worker. So this happens automatically. And whenever any hundreds of nodes come to the cluster and scale in, scale out happens on a regular basis, so this node watcher will always continue to watch the node events, and it adds the node label appropriately for all the nodes. And this is the automation. I mentioned about the adding the condition checker label into our kubelet configuration. When you go to the etc systemd kubelet.service.dkubadium.conf, you can find some environment file. Environment file is nothing but the kubelet configuration, whatever we specify to run with the kubelet. So this is the file. So that has the image full. What is the image that kubelet wants to have? That is a pass image and the storage, sorry, the resource limits. Everything will be mentioned here. Along with that, we'll be adding the node labels as node.kubernetes.io/worker. So the new node will be added to the cluster with this role, and the node watcher pod will take care of adding the appropriate role to the node. Let me see if we have the node. Yeah, I can quickly give you the demo. Okay, you can see the node role is none. So I'm adding the condition checker label node 01 node.kubernetes.io/worker. Okay, so still the node role is none, but the label is added to the particular node. Then we are creating a deployment. Okay, we'll wait for part to come up. It's downloading the image. Okay, still pulls the image. Okay, so the now pod is running, and we can check the logs. So you can see the modified happen. So the node 01 is the worker role is added. Get nodes. Yeah, you can see now the worker is added with the role called worker. Yeah, this is what we have done in our Kubernetes environment. We have a shared environment with thousands of applications running. So this solution helped us to move on with the work on a daily basis. Thank you all. And I have specified the reference links here. So this is the first GitHub link. When we were into the chaos situation, we created the issue with the Kubernetes, and it doesn't help. There is no solution out there in the Kubernetes community. And we found our in-house solution, and we are contributed to the open source community in Docker Hub. Thank you all. Hope you enjoyed the demo. Thanks, Prithvi.
Thanks, Jaffer. It was indeed insightful to know about the solutions that you have provided to the open source world. I would leave the floor open for questions. If we have any questions for Jaffer, we can surely take them. Okay, so as I not see any questions, but there are a few comments for Jaffer in the chat window. So thank you, Raju and Vivek, for the comments, and hope you all enjoyed the demo and the meetup itself. We would like to conclude the meetup, but before concluding, I would just invite you to join in the Slack community once again. Queries, contributions, and learnings are presented there. We would also like to invite you to put forward any queries you have in the Slack channel, so that you can come forward and contribute to the open source community. As you all know, Litmus is open source, and we invite contributions. And I hope that you enjoyed the meetup, and the recording will be sent to you as well, so that you can go back. So looking forward to see you all in the next meetup, which will happen on the third Saturday of the October month. And hope you have a nice day, folks. So goodbye from our side. Cheers, and see you next time.
Thank you, everyone.
Thank you, everyone.
Thank you, everyone.
Thank you, everyone. Thank you all the presenters for the wonderful demo.
Thank you. There's some questions in the chat if you want to take it off, Jaffer.